Good afternoon, everyone. Is my voice
Good
audible?
afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon, ma'am.
Yeah. Let me introduce myself. I'm Dr. Shubhra Rani Patra. So I have been working here since last 1.5 years, and yeah, I'll be your instructor for this data structure and algorithm course. I hope you guys are doing well and keeping safe. Yeah.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So this class I'll be only covering the syllabus and the course plan, how we'll go till CAT 1, okay? And I'll touch upon a very non-technical aspect of data structure in the layman's perspective. Let me share my screen first 1 minute. In case of any doubts, you can interrupt me anytime and let me know, okay? Okay, let me share the screen. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Oh, okay, great. So yeah, let me just first tell you. I'm sure most of you, all of you, have all what are the things. How do we go about the assessments? So there will be the quizzes almost every day, and the weightages are there are two quiz sets and assignments. So the weightages for quiz 1, quiz 2, and assignment is 10, 10, 10 each. Okay, and the pattern of quiz is mostly it will be of MCQs and also can be of short answers that will be in the Moodle. Okay, I think the Moodle is yet to be updated, so as of now I will update the things in the Teams. Okay, so you can download the syllabus, the course plan, and the books also in whatever our session, the PPTs. Okay, till the time we are not in the Moodle, it will be very soon in 1 or 2 days. I hope it will be updated. So till the time we'll work on Teams. Fine? Yes?
Yes, ma'am. Okay, ma'am.
Okay.
Yes, ma'am.
Yeah,
Yes,
and
ma'am.
yes, okay, great. Then I'm sure you must be knowing the attendance. So there is 75% of attendance requirement uh, for sitting in the exams, both like all CAT 1, CAT 2 as well as the FAT. Now let's see what is the syllabus. So the course code that we know it's CSE 2011, having 3 lectures per week and 2 practicals, and the credit is 4. Right. So let's see what are the course objectives. So basically here we will cover the basic concepts of the data structure as well as the algorithms. Okay, and we will see the linear and non-linear data structures, more detail into data structures, and what are the operations performed in the data structure in terms of searching. Okay, and we'll see one important aspect, that is the time complexity of the data structure. So to start with, or uh, if I want to brief it about the data structure and algorithm, basically like from now today onwards till the time you are working in any computer science field, you need to handle the data first, right? So when you are handling the data, basically you will get the data in mostly in terms of the raw data, which will be in the unstructured form. One second. Sorry. Yeah, you will be back. Yeah, I'm sorry. So yes, basically, uh, whenever we are dealing with the raw data, first we need to do the structuring of the data, right? So the data structure part is that. Now dealing with the data means what? Given you will be given a set of data, you will be given a problem to solve in the data set, right? Otherwise, what is the point of using the data? So from the data set, you will be asked to solve few questions, okay, from the data. So that part is the algorithm part. First you need to structure the data, then you go for the step by step solving the problem is the algorithm part of the data structure and analysis. Okay, I hope this is clear. Yeah.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So, yeah. So these are the expected course outcomes, where we are first will understand the analysis and time complexity of the problem. Will come in lot more detail. There is a separate module to it, and we'll see the linear data structures and the operations, non-linear data structure and the operations, sorting and sorting, as I said, and graphs, algorithms, then trees of the operations related to it, hashing. This is also a type of data structure, and what for it is used, that also will cover in the basic data structure, and we'll come to the advanced data structures and we'll wind it up. Okay, now comes the like yeah, as I said, because you will be handling every step of your life whenever you are working in the computer science field, you will be handling the data. So you will have first given the data, you will be having you with this course, mostly you will be able to solve a kind of problem given to you. So the thinking ability has to be developed. Why? Because it's not only just solving a problem, how efficiently you solve the problem. What is the time it takes to solve a problem? Given a problem, we can approach it, and the logic can be very like different. It can be many. You can have many logics to it, right? So which one is efficient, which one is more efficient? So that will come with your like as much as you practice, as much as you try with different types of problems, right? So this is the outcome. Now to start with model wise, there are 8 modules. Okay, starting first module is introduction to algorithm analysis, where the basic algorithm and data structure, the fundamentals are explained. Then comes the time complexity. Time complexity in general, time complexity of all the data structure which we are going to use, which one is performing better based on the types of data structure and based on the given problem. That has to be explained in this one. Then comes the linear data structure, starting with I'm sure most of you have worked in the C programming, so where you have handled the arrays, then stacks, Then the queues will come. Then the linked list. There are many types of linked lists to it, which solves specific problems that we'll see. Then comes the module 3, where we are working on sorting and searching. So the operations in the data structures that we will see. Okay. So what I will do is I'll explain the course plan. Let me just go ahead with this one. So yeah, so there are types of sorting techniques and searching techniques that we are going to cover. Now in the next module, we are handling the nonlinear data structures. Okay, so where we'll see what are the trees and what are the types of trees, the binary trees, binary search trees, and how do we go about the operations of the trees. Okay, similarly in the next module, we'll see what are the graphs, the types of graph, what are the searching in the graphs, the depth first, breadth first, and the minimum spanning tree, and what for each algorithm is what is it best used for. Similarly, hashing. Why are we using a separate kind of data structure where we are using hashing? Okay. Next comes module 7, where we will see the heaps and balanced binary and search tree. So what is the real life applications of it? Then finally we'll go to the module 8, which is covering the recent trends or more of kind of the research analysis in the data structure, which will be covering the NP hard and NP complete problem. Basically that will be the area where still the like ongoing research is there. Okay, so those things will cover in the module 8. Okay, I hope the entire syllabus is clear with you. Just a brief I am giving, not the concepts, just what are we going to work on it. Okay, so these are the textbooks, the Coleman and Weiss, and reference books are Horowitz and Mellon. So I'll upload all the books in Teams as of now. Okay, so basically Coleman we are going to follow, and the rest of the things also we are welcome to use any of it, whichever is suitable and required. Okay, now just before going to the further about this, let me just just 1 minute. Let me share the course plan also. What are the things I'm going to cover in? I hope my screen is visible.
Yes, ma'am.
You are able to see the doc, right? Okay. So, so now till Cat 1 we have 15 lectures, right? So 15, 15, 15 each till Cat 1, Cat 2, and the final FAT. So till Cat 1 we will be covering till, let me see, what I'm going to do is, instead of straight away switching to the time complexity part, it's better to have knowledge about the symbol, the arrays, and the basic like linear data structures, the stacks, the queues, the linked list, single linked list, double linked list. Then with this, having idea of this data structure concepts, the infix to prefix, there are many things we are going to cover in this particular module, which is basically the second module. We will now next we'll see what is the time complexity of each and every data structure, which we have already covered. Instead of having a generalized view, I like, from my opinion, it's better to start understand these concepts first, then after that come to the and time complexity part, time and space complexity part. Then we'll cover all the time and space complexity, the best case, the worst case, the big O notation, the average case, uh, then the analysis of the algorithms, the iterative algorithm, the recursive, non-recursive, all the algorithm parts that we will cover in the next module, which is the first module. Okay, then we'll see third module is we'll start the searching operation. Okay, the linear and binary search. I hope that would be it for the till cat 1. The next onwards, what are the trees, graphs, and those things we'll cover in the cat 2 part. Okay, clear?
Yes, ma'am.
Yeah, now let's come
Yes,
to
ma'am.
answer. course objective or what are the things I'm going to cover in this class. So it's very non-technical again I'm saying. So we'll see what are the basic data structure and algorithms and what is data structure. As I said, what you are going to do in a data structure, you are having a raw data, you are arranging, organizing it in terms of like in the memory, you are organizing it so that it will be in the structured format. Now algorithms, as we know, it's a step-by-step process for solving any computational related problem. Okay. And analysis is how well you are like what is the time it is taking and which is the best among your like algorithms which you have prepared, which is the best you can say. So that analysis you need to do, right? And so that you can choose the best, right? So that is the analysis part. Yeah, so basically next is when you are taking data structure, applying the algorithms. Once you are done with this, then you go to the program coding part. First to have the data in the structure format and uh, develop the logic for it, then go to the coding part. Okay, so as I said, let me just briefly explain about the difference between the algorithm and programs, because like when you are handling a particular problem, suppose you are handling a particular in terms of like if you are given a data set for from a medical and you are asked like, what are the age groups for the cancer patients, okay, how many numbers are there in the less than 50 or above 50 or 70 to 90. So this is just a simple problem. You are asked to do that. So for that, what you are going to do? You are going to have the past history of the all the patients in the hospital, okay, and the past history in terms of you will see if, with respect to a particular person what would be there, the variables, the health related variables, okay, or health related parameters you are going to see, okay. Then what you will do, then so once you are arranging those parameters in terms of some structured, you can say array, list, or it will be like whatever is the problem, which data structure you need, you will choose that will come to know in a while. As of now, just what you are doing is you are just imagine you are given a data, you know which data structure to be used. Now you go to the algorithm part. Algorithm part, directly instead of directly going to the program and implementing, starting the code, you design the process, right? You design the logic for it instead of like writing the code and then and there working on it. It's better always to have a design for it, okay. So program part is you are going once you are done with the design, you are going to implement it. Similarly for algorithm, who is going to work on it? Basically the person who is having the domain knowledge of it, okay. And just like if you say, okay, I want to do the health analysis of the cancer patient, so I am a programmer, I want to work on it, but you are not you are not the person who is actually involved in the hospital, or you can say the doctors or nurses are those persons, they have the domain knowledge of it. They can better have this analysis in terms of pen and paper or in a word document. They can have this logic when we are asked to solve this particular problem. So they better know the domain knowledge. So they will give the rough algorithm. It can be of any, you can say just English like language. They can write in terms of some mathematical, if they want to put some mathematical formulas also they can put. So it's just like pen and paper thing, okay. Unlike the programming where you are doing the programming language, the coding part of it. Whereas here in algorithms, basically you need the hardware. It is the hardware and software, the operating system independent, because you are just designing the logic, and programs are hardware and software operating system dependent. And in algorithms, what you are doing is you are analyzing it. Once you are done with the algorithm, you have developed a logic, then you are checking the time and space complexity. That means what? I'm just briefing you. Space complexity, what is the memory it is taking in your computer memory, like the variables are taking what space. So that it is not space in terms of bytes or bits you are I'm talking about. It will be in the form of functions. Okay, the space functions. Similarly, time also, it's not in terms of minutes or seconds. Here we are not at all doing that in algorithm part. We are putting in terms of functions. Okay, the time functions, if we can consider it will be of order of one is that means what we are considering, it is taking 1 unit of time. It can be of any unit, but we are taking each line is taking 1 unit of time, like that. Okay, I hope you are understanding the difference. The program where you are actually testing it and finding, okay, this code is taking 3.4 seconds to run, right? Whereas here, what you are doing is you are just line by line, how many codes are there, and what is based on the repetitions, based on the looping part, you are seeing what is the time function it is taking. Okay, is this clear or it is getting too much complex? Yes, let me know.
Yes, ma'am. Clear.
Yeah, okay, good. So yes, we'll see the data structure types and applications, some of the real life applications and algorithm part. Now let's see. I have told you many times, but yeah, let's see. So from this figure, what do you understand? What is the left side represents? Does the right side represent? Yes, and you.
Ma'am,
Hmm.
and the left side is not properly arranged,
Yeah.
whereas right side is properly arranged.
Yeah, so like you are given the raw data here in terms of all the fruits are given, and here you have put it in terms of structured data. So if I ask you to get some carrots or tomatoes, then you from here it is very easy to fetch those things, right? So here what you are doing, you are organizing the data. So there are various types: arrays, linked list, queues, trees, hashing, and graphs. Now to start with, if you see arrays, basically in the memory, if you see, arrays are sequential data, which are arranged in terms of, it is a contiguous memory, like one after another you need to arrange, and they are of fixed size. Whereas in linked list, if you see, sorry, this is also a sequential data. Okay, but you can like, this is not fixed size. And in the linked list, what you have is, along with your data value, you have the address, another like you have one more compartment for it, where you keep the address. That means what, instead of array which is arranged in like suppose you in the memory, suppose you have the space free from 1000 to 1010. If you are having 10 elements, that means what, it is 6. So if you want to fetch any of the element in the array, you know the sequence. If I ask you 8th element, then you will go straight away to the 1008 index and get that element. Okay, similar. Whereas in linked list, what you have to have is, since they are arranged in like in the memory, they are not arranged like one after another. That's why we need to have a tab of the address. Along with the data, we need to have a tab of the address. So that address will be kept. It will be sequential, but that address, if I want to have the access of the third element, then so this address is should be pointed to the second element. Okay, so that is the address part, right? So that sequence you need to understand. We'll go to a lot more detail about the linked list, that the idea will be clear. Now these are the tree, then queue and stack. So the tree is, we can say, the nonlinear data structure, where it is not arranged sequentially, whereas queue and stacks are linear data structures. Now comes to the algorithm part. So this I have explained in lot more detail. In algorithm, what you do is, you do follow a step-by-step sequence. Once your data is structured, the unstructured data we had, now it is structured. Now what to do with that? What to do with this data? So let suppose I have asked you to make a salad out of it. Okay, then what do you do? What are the process you follow? So you clean the vegetable, you cut it, you make the saute of it, then you serve it. So these 4 steps are coming into under the algorithm part. Okay, so you are solving a particular problem. Given the data, you are solving the problem of like, okay, I just have asked with this, I have just asked you to serve a fruit salad. Okay, so this part you have done in the data structure, this 4 thing you have done in the algorithm part, right? And some of the real life examples, if you see, so if the queue is a data structure, right? So here, let's suppose you are going to a concert and you want to have the tickets. If you are going in bunch, it won't help. So better go in the queue, right? Similarly, there are many other examples. Now, similarly, the tree data structure. So what you do is, let's suppose you are given this horse family, and like one by one they have given the relationship between the family members. Okay, so if we see how white fox is a child of Toad and Diamond, and so on and so forth. So this is a very small data set where you have like at max some 7 like elements are there, right? What if the data is more? So if I ask you in along with this big like explanation, if I ask you like who is the grandchild of Todd, then by just having this, it will be very difficult to understand, right? So what do you do? So better you arrange in terms of based on this idea given, you arrange it in terms of tree structure. So this is the particular case where tree is useful. Tree data structure is useful. It won't be useful for all the cases. Similarly, this here Q is the most useful data, like data structure that to be used, right? Now comes the graphs. So graphs is here, let's suppose this is the diagram of the India map, which is having the flight like paths from one city to other cities. Now if I ask you to from New Delhi, which is the best like shortest way to reach to Chennai or Bangalore, for example. So there can be many paths you can cover. So which is the shortest? Shortest means in terms of what you would ask. So it can be in terms of price. It like you can say what is the least price I can travel to Chennai. What is the least price I can? What is the least distance I can travel to Chennai? So those are the things that you can work with the help of graph data structure. Okay, is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, now the types, if you see the data structure, so there are primitive and non-primitive data structure. Primitive means whatever you are given, given the data, whether it is the integer type, it is a float type, it is a character type or boolean type. So what is the type of the data that we call it as a primitive data structure. Now, the non-primitive data structure, that also is divided into physical and logical. So physical is actually, it is taking some space in the computer memory. Okay, it is physically actually present. So when you declare an array, you are taking some memory from the computer memory. Okay, some space from the computer memory. Similarly, same as linked lists also, they are physically present. Whereas this logical data structure, which are like stack, queue, trees, and graphs, and hashings, and others, what they do is they have some logical concept. Okay, the way the queue is having the concept only, but how is it prepared, like how you are preparing the queue data structure, how you are taking the memory to develop this queue, you are taking using either array or linked list. Similarly, tree, you are using either array or linked list, and so on. So these are the logical data structure which are having some logical concept. Tree is having some logical concept, graph is having some logical concept, and they are used in the RSN linked list. And the operations, basic operations this data structure perform is the searching operation in the array or linked list or stack or any other data structure. Similarly, sorting, how are you arranging it in terms of sorting, whether ascending or descending, and like if you want to insert an element, how do you do that? If you want to insert an array or in linked list or in stack, how do you do that? Similarly, deletion. And similarly, if you want to update, do the updation, removing one and inserting one, how you do that? Okay, so these are the basic operations that are performed in the data structure. Now, if we see, so that this data structure can be also divided into linear and non-linear. So, linear data structure, as I said, which are arranged in a linear sequence or in a contiguous memory. Okay, and non-linear data, for example, array is linear data structure. You declare the array with certain space or elements, then the you can feed the data into that array in sequential manner. Okay, non-linear data structure where data are not arranged in any sequences. For example, trees and graphs are non-linear data structure. Now, if you want to divide it in terms of homogeneous and non-homogeneous, so array is having the data structure having similar type of data types. If you want to put only integer data types, you can use only integer array. If you want to put characters, then you can use the character array. Okay, and whereas non-homogeneous, where you can put both the integer characters and other data types together in a structure. Okay, so that's the difference. Now, if we want to divide in terms of static and dynamic, so as I said, array is having the fixed size of the memory locations. Once you declare the array of this size, you can't just like that, you can't add any other elements to it. Okay, so if you have already fixed it. Similarly, dynamic is like on the go, you can increase uh, the size of your linked list in terms of nodes. Okay, so that I will explain in detail. So what you do is, linked list is not having any particular fixed size, so we have the liberty of using adding whenever we want. That means what, we are using less memory, unlike array where we don't know much how like how many elements we need in the first place, right? So that is the difference, the static and dynamic data structures. Is this clear?
Yes.
Yes. Any doubts? So these are very what can I say, very basic concepts I have touched upon. Not I haven't worked on any particular program or anything. Just the idea behind the data structure. Okay. I hope this is clear. The syllabus, the course plan, and the basic concepts. In the next class, we'll start with the array. Okay. And the types of the array and what are the operations that we work on with the array. I hope that's clear. We can, if you have any doubts, you can let me know. Otherwise, we can wind up the session for today. Yes. We need. And one more thing. One more thing. So for the digital assignments, this time we are going in a different way. What we are going to do is, so there are various platforms. You must be knowing the lead code, the interview bit, the GitHubs, and the Kaggle. So you need to. I'll tell you how and when. So you need to register in those if you haven't, and you need to solve a particular problem. Then based on that, you will be graded. Okay, which problem and all I'll let you know as the class goes. Okay, so all the digital assignments would be in any of those platforms. I'll give you the details about the types of the platforms that has been given to work upon. Okay.
Okay.
Yeah, great. Okay, yeah, that's it. I think we are done for today. If anything is there, please let me know. Otherwise, we'll wind up the session for today.
No, ma'am, nothing is there.
Okay. Okay then, yeah. Otherwise, you can tell me anytime in the group or WhatsApp group you have created. I hope all of you have joined there.
Ma'am,
And
I joined. I didn't got the link.
you haven't
Actually, today only I joined the channel. Means I modified the slot and then joined the channel. So that's why I'm not in any of the group yet.
okay. I'll just check it and I'll send you the link. No worries.
Yeah. Yeah.
Okay.
Thank you.
Okay then, yeah. Okay then, let's wind up the session for today. We'll meet, I think on Wednesday. Yeah, on Wednesday we have the class. theory. Okay then. Yeah.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you.
Thank you, ma'am.